Hello and welcome to the topic Powers and Roots for O levels and IGCSE. Let's get started. A power or exponent is a number that indicates how many times a base number is multiplied by itself. There are two ways to write it. We can write it as base given cut resume. It can be written as base and then we create this upwards arrow and then write the exponent. Or we can write base and then type the exponent in superscript. This is the most common way of writing powers. For example, 2 to the power 4 can be written as where 2 is the base and 4 is the exponent that is written in superscript of 2. It means that 2 is multiplied by itself 4 times. In this case, 2 to the power 4 would mean 2 multiplied by 2 multiplied by 2 multiplied by 2, and that would equal 16. Similarly, 3 to the power 3, also read as 3 cube, is 3 multiplied by itself 3 times. It is 3 times 3 times 3, that is 27. And 4 to the power 3 means 4 cube. It also means 4 multiplied by itself 3 times. 4 times 4 times 4, and that is 64. Squares mean their power is 2. A square of a number is the result of multiplying the number by itself, or more simply, a number with the power of 2. It is represented as base and then the pointing upwards arrow 2 or base and superscript 2. For example, 2 square means 2 times 2, that is equal to 4, and 3 square means 3 times 3, that is equal to 9. 4 square is 16. Cubes mean power is 3. A cube of a number is the result of multiplying the number by itself threefold, or simply a number with the power of 3. We have seen how they are represented, only in this case the exponent is simply directly 3. 2 to the power 3 or 2 cube means 2 times 2 times 2, that is 8. 3 cube is 27 and 4 cube is 64. A root is the inverse operation of a power. Initially, when we are multiplying the number by itself 2 times or 3 times to get the power, we are going the reverse method in this case. It is represented in two distinct forms. The first one is to write root and then draw the symbol of root followed by the base. In case no root is mentioned in this representation, default is considered, which is 2. The other method is to write base and then 1 over root as an exponent. An example could be root of 16. In this case, notice that there is no number mentioned. It means that we would consider the default, and the default is 2. So the root of 16 is 4 because 4 times 4 is 16. As we can see, 4 square is 16. So root of 16 is 4. It is the inverse operation. Cube root of 27 is 3 because 3 cube is 27. Notice here that 3 is specifically mentioned before the symbol of root. It is important to mention the number of root. If none is mentioned, it will be considered default, which is 2. Square roots is the square root of a number is a number that when multiplied by itself gives the original number. There are 3 methods to represent it. Base is given under the symbol of square root, and then 2 is written before it. 2 might not be written before it, or simply we can write it in exponent or in superscript as 1 over 2. An example could be root 4 equals 2 as 2 square is 4. Root 9 is 3 as 3 square is 9, and root 16 is 4 as 4 square is 16. Cube root of a number is a number that when multiplied by itself 3 times gives the original number. It is similar to square roots, but rather than going for squares, we are going for cubes. As cube root of 8 in the given example you can see is 2. Why? Because 2 cube is 8. Cube root of 27 is 3 because 3 cube is 27, and cube root of 64 is 4 because 4 cube is 64. There are two methodologies to represent it as mentioned here. First is to write 3 followed by the symbol of a square root and then write the base. Or simply, we can write the base and then write it in exponent as 1 over 3. Now let's talk about some other powers. Powers are not limited to 2, that is a square, or 3, that is cube, and can be any number. But the general concept remains the same. For example, 2 to the power 4 would mean 2 is multiplied by itself 4 times. 2 times 2 times 2 times 2. This is 16. Similarly, 5 to the power of 5 would mean 5 is multiplied by itself 5 times. So 5 times 5 times 5 times 5 times 5 would equal 3125. Similarly, roots are also not limited to 2 or 3, that is, square roots and cube roots, and can be any number, but general concept remains the same. For example, 4 root of 256 is equal to 4 and 4 root of 16 is equal to 2. Now, it is important to note that anything with power 0 is always 1. The number of the base does not matter. If the power is 0, then the answer would be 1. In this example, we are supposed to find 2 to the power 6, 7 to the power 9, and 4 to the power 2. So let's put it on the side and let's get started. 2 to the power 6. It means we have to multiply 2 by itself 6 times. So we can write 2 multiplied by itself 6 times. Now for simplification, let's make pairs. We can make 3 pairs. That means 4 times 4 times 4. It would mean our answer is 64. So let's put it on the side. And then let's get started with the more complex question. 7 to the power 9. It sounds and looks a little bit of dangerous, but we can do this. How can we do this? We can do this by simply writing 7 multiplied by itself 9 times. So let's do that. We have 7 multiplied by itself 9 times. So let's make a few groups. We have 7 to the power 4 and 7 to the power 5. Two groups. So let's multiply them and then get their answers. In this case, we get 2401 multiplied by 16807. That's 7 to the power 4 multiplied by 7 to the power 5. We can divide it in smaller groups as well. For example, 7 squares. But we are going to stick to this one. So that gives us the final answer, that is 7 digits long. So let's put it to the side. But let's do a recap of the first topic that we learned. In the first chapter, we studied how we can put and read these long numbers in simple forms, how we can put them. So let's do that and place the commas in their very respective places that make it easier for us to learn. So how do we do that? We start putting commas for every 3 digit from the right. And for these commas, we get this value. Now, how do we read that? If we remember, if there are 2 commas, we are in millions. So we would go 40 million. How do we read the further ones? We read them by following along. We have 353,000. So 40,353,000. How do we read the last 3 digits? We read them simply 607. So the full value can be read as 40,353,607. And finally, we have 4 squared. So let's type it 4 times 4, and that gives us 16. So that's our answer. Now, let's take a look at a few tables that will come in handy for squares, cubes, and roots. First, let's study the table of squares. Now, in this table, the values on the left are the numbers that we must remember, and the values on the right are their respective squares. For 1, we have 1. For 2, the square is 4. For 3, and the 3's square is 9. For 4, the fourth square is 16. And this pattern continues so on and so forth. In this table, it is also important to note that since root are the inverse function of powers, the values on the right, if they are given, they can be converted into the values on the left. The values on the right have the square roots to the values on the left. In this case, that means square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. And this pattern continues, so on and so forth. So let's move ahead to the table of cubes. In the course of O levels and IGCSE, the only highlighted values are the necessary ones that we must remember. The other values are just here for your reference. So that means 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125, and 10 cube is 1000. And inverse means we are going cube root. So cube root of 1 is 1, cube root of 8 is 2, cube root of 27 is 3, cube root of 64 is 4, cube root of 125 is 5, and cube root of 1000 is 10. That's it for this video. I hope you have a good understanding of whatever we have learned so far. Thank you for watching. If you like the video, make sure to like, comment, and subscribe. Until then, see you later. Have a good day.